we have given that plane A is perpendicular bisector of segment BD at point C. First, we have to prove that segment BE is congruent to DE. Next, we have to prove that BF segment is congruent to DF, and angle FBE is congruent to angle FDE. So let's put that. First is that BE segment is congruent to DE. We have to prove this statement. BE segment is congruent to DE segment. We have given that plane A is the perpendicular bisector of BD segment at point C. It means that BC segment is congruent to DC. So we can put red mark of BC segment and CD. We have that BC segment is congruent to DC segment because plane A is perpendicular bisector of BD segment at point C. So we have a statement because plane A is perpendicular bisector of BD segment at C. So we have right angle because E and F points are on plane A. So CD segment is on A plane. So we have right angle between BC segment and CE segment because plane A is perpendicular bisector of BD at point C. It means that plane A is perpendicular to segment BD, so we have right angle, and point C is the midpoint of segment BD. So BC is equal to DC, so we have that segment BC is congruent to segment DC because plane A is perpendicular bisector of segment BD at point C. It means that this segment is congruent to that. Next, we can write that segment CE is congruent to segment EC by reflexive property. So let me write this, that CE segment is congruent to EC by reflexive property. What else? Because plane A is perpendicular bisector of BD, it means we have right angle BCE is right angle and DCE we have here right angle too. Because plane A is perpendicular bisector of BD. So between plane A and segment BDC we have right angle, and between plane A and segment BC we have right angle too. So we can write that angle BCE is congruent to angle DCE. So now, if we have congruent sides, C is congruent to EC, and congruent angles by side angle side congruence postulate, we have that triangle BCE is congruent to triangle DCE. This triangle is congruent to that triangle. It means that corresponding parts of congruent triangles are congruent. So we can write that because triangle BCE is congruent to triangle DCE, it means that corresponding parts of congruent triangles are congruent. It means that segment BE is congruent to segment DE, because this triangle is congruent to that triangle. It means that BE segment is congruent to DE segment. So we have answered to first part. BE segment is congruent to DE because triangle BCE is congruent to DCE triangle. So next we have to prove that BF is congruent to DF. BF is congruent to DF. So now we have to show that BF segment is congruent to DF. Again, we will show that triangle, now BCF, is congruent to triangle DCF. And if we show that these two triangles are congruent, then corresponding parts of congruent triangles are congruent. So it means that BF is congruent to DF. So again, from the beginning, we have given that plane A is perpendicular bisector of BD segment. So from definition of perpendicular bisector, we know that if plane A is perpendicular bisector of BD at point C, it means that we have that plane A is perpendicular to segment BD. So we have right angle here and there. We have right angle because plane A is perpendicular bisector of BD. What else? Point C is the midpoint of segment BC, because plane A is perpendicular bisector of BD segment at point C. So C is the midpoint of BD. So it means that BC is congruent, BC segment is congruent to DC segment, like we write before, because plane A is perpendicular bisector of BD segment at point C. So let me copy this, because plane A is perpendicular bisector of BD segment at C. This we have given at the beginning. So first we use information which we have given. Next, what else we have? CF is congruent to FC by reflexive property. Segment is congruent to FC segment by reflexive property. What else? Angle BCF is congruent to DCF. Why? Because A is perpendicular bisector, so it means at point C that segment BC is perpendicular to plane A, and CF is the segment which lays on plane A. So angle BCF is right angle, and angle DCF is right angle because plane A is perpendicular to BC. So we can write angle BCF is congruent to angle DCF, because plane A is perpendicular to segment BD. So now again we have sides congruent, BC is congruent to DC, angle BCF is congruent to DCF, and CF is congruent to FC. So again we can write that by side angle side congruence postulate, triangle BCF is congruent to triangle DCF. And now, because this triangle is congruent to that, this triangle DCF is congruent to BCF, it means that corresponding parts of congruent triangles are congruent. It means that BF segment is congruent to DF. So from this we have that BF segment is congruent to DF segment. This is what we need to show, that these two sides are congruent. So from side angle side congruence postulate we have these two sides are congruent because triangle, one more time, BCF is congruent to DCF. And the last question, we have to show that angle FBE is congruent to FDE. So let me use different color. We have to show that angle FBE, this angle is congruent to angle FDE, to that angle. Let me use maybe red color. This angle is congruent to that angle. We already show that BE is congruent to DE. We show this. BE segment, let's put 2 marks, is congruent to DE. And we show that BF is congruent to DF. BF, let's put now 3 marks, is congruent to DF. And we know that FE is congruent to EF by reflexive property. So let me write what we have. So the third question, we have that BE segment is congruent to DE. We already show this. And BF segment is congruent to DF. What else? FE is congruent to EF. Segment is congruent to EF segment by reflexive property. So we have side, side, side. So from side, 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 congruence postulate, we have that triangle FBE is congruent to FDE. It's congruent to FDE. So if these two triangles, this and that, are congruent, it means that corresponding parts of congruent triangles are congruent. So it means that angle FBE is congruent to angle FDE. So this is my solution.